Welcome to the individual video story presentation, Spring 2018 SkillCourt version 10.0, user case SC 1147, implement and refactor sequence class. My name is Sandra Hurtado, and I'll be explaining to you about implement and refactor sequence class user case story and how I created it. First, let's start with the Mingle board. So Mingle was introduced to us in senior project. Basically what it does is it helps us keep track of what each member is doing and break down big tasks into smaller tasks that each of us can work on at the same time, and it just helps us organize ourselves better. The story that I'm going to be presenting is the one in Sprint 3, implement and refactor sequence class. And the way this story came to be is our product owner is a soccer coach, and he has several users that currently are either interested in the program and the application, or they are in the process of using it, kind of like the beta version because it's not completed. And they had some feedback, and the feedback that they had is they wanted to have more features available for them. They thought that the application was great, but it could use some improvement by allowing them to personalize the application as much as they can. One of the suggestions was that it would be cool if currently the system only allows them to do a random sequence, but it would be cool if there could be a sequence that they can handle themselves. So as a team, we had to do a lot of refactoring existing code in order to make it more scalable for future features that will be added on. So in my case, I was focused on the sequence class. And for example, they had only one mode, and that mode was taken care of in the main activity. So what I did was I created a sequence class, and that allowed for me to add an additional mode, and also future classes that will be working on SkillCourt can add them. So the description says, as a developer, I should implement sequence class so that the user can have a variety of sequence modes to choose from. Our acceptance criteria is sequence class should have random sequence mode implemented, refactor current use of sequence in game service, allow future sequence modes to be added through methods, and unit tests should be done. So if we move over to Sprint board, Sprint board basically has all the stories that are currently in the works for that given sprint, and you are allowed to divide that even to smaller tasks. So for example, you have different columns that says to do, in dev, testing, and done. So it helps us keep track of what is the activity that's going on during that sprint. And every time we have meetings in the morning, we can tell each other what we're working on and give details, and if there's any blockers going on, we can tell each other. And also we would know if we see a story long enough in dev, if they need any extra resources, we can all keep track of this. So since this story was created in Sprint 3, everything is done, but it shows the different tasks that I had. I had to create sequence class, I created documentation, I had to refactor how it was used in the main activity and move it all to the sequence class, and implement sequence mode, which added a new sequence mode, which was the manual mode. Okay, as I explained how we used the Mingle board for this project, I will now move on to explain the documentation for the user case story. And here are some basics of the user case story. So our actor was the user, person that's going to be using the application, and the preconditions in order to get this feature working is you must have the physical pads turned on and the application opened on your Android device. Both device and the pads must be connected to the same hotspot of name SkillCourt and password SkillCourt, and wait until the pads are identified by the application. In order to get this started, you will select the play button, and you would be displayed with different sequence modes that you can choose from. you can select random sequence, and then the paths should light up randomly. On the right, you can see our user case diagram, and it's a design architecture for sequence. We design a sequence, and it will be extended to either a manual sequence or a random sequence. Here are screenshots to better display what I just explained. So the way it would work is once you open up the application and have your paths connected, you will be displayed on the top right the number of paths that were connected, and you'll hit the play button, and that will tell you to please select a mode, random or manual, and you'll select the one of your choosing, play the game, and at the end of the game, it will show you how many hits you had and the overall score that you'll get. Here's the sequence diagram for the architecture of sequence. And the way it works is you would be, the actor, being the player, will be on the home fragment. They will select to play, and it will send you to the sequence fragment. And then on the sequence fragment, you will be prompted to choose between two modes, manual or random. A sequence controller will get that mode that you did, will set the sequence to either random or manual, go to the sequence class. Sequence class is the main component of everything, and is the one that will be in charge of creating either a manual or a sequence mode. Then, once the sequence controller gets that sequence mode that you selected, it will show the sequence to sequence fragment, and that would be sent off to the paths, and then they'll be able to display what you selected. Here's our system deployment diagram. We have SkillCourt running on an Android device that it has hotspot available, and we have the pads that will also be connected to the same hotspot as the Android device. The pads consist of a Raspberry Pi and LED strips. For our system design architecture, we used an MVC model. You can see there is model, controllers, and view, and service. I focused on the sequence fragment and the sequence controller. And here is the minimal class diagram. I focused on the sequence fragment and the sequence. So in order for us to make sure that this feature was fully implemented and that it works fine, we created different test cases for features, and I concentrated myself on what I had implemented, which was sequences. So I created a sunny test case and a rainy test case, and for the sunny, I tested that test sequence connection. Description summary of test. As a tester, I'm supposed to make sure the sequence class is getting correct input from the controller. Preconditions must be signed on to the application, need to have at least one pad connected and selected random sequence mode. Expected result, random sequence mode. Actual result, random sequence mode shown on the pad. Status was pass. And the rainy day was test no sequence connection. Description and summary of test is, as a tester, I'm supposed to make sure that a sequence must be selected in order to play a game. Must be signed on to application, need to have at least one pad connected and selected random sequence mode. That's for precondition. And expected result is, if no mode has been selected, you stay in the sequence fragment, no transition to game fragment. Actual result, stayed in sequence fragment, and that test case passed as well. Okay, so now that I showed you all the diagrams that were created for the user case story, we'll move on to check out the code. Okay, so here's the code. Here it shows the sequence fragment. This is basically where I control the UI and show the user the different modes. Now, the one that was in charge of everything and the one that was mainly controlled the whole sequence was the sequence class. So the way that it worked is we had a list of pads that will store the amount of pads that you're going to have connected to your application. And we can see that it creates a sequence object, and that it passes on the game mode that the user selects. The game mode will have switch statements, random or sequence. So random, the way it worked is, for random you must have amount of pads greater than 2, and while you have several pads connected that is greater than 2, you'll send a number to the pads that are lit, and then what you're going to be using is the math.random, so it can display different amount of numbers that will be selecting based on the pad size. So if it wants pad number 3 to light up, it'll light that one up, and it's just going to be in a random order. And then the other case that you have is sequence, which is the manual sequence. Now the manual sequence, we created a double-ended queue called sequence, and you will, as the user sees the sequence fragment that would show you the pads that are connected, the user will select the pad in the order that they want, and that was stored into a queue. And then the way it decides is by the mCurrent pad lit, it gets sequence.poll, which will get what is on the head of the queue, and that will light up. And then the head of the queue will be added on to the last part of the queue. So once let's say 1 was the selected first one, pad number 1 lights up, then it moves on to the second one. But that front that was already taken out of the queue will be put back to the end of the queue. Alright, so here's a quick demo of how the application works with the changes that I made. So at this point, you have already connected to 4 pads onto the application, and you are ready to play a game. So you just hit the button right over here, and you'll be redirected to this fragment that allows you to select the game mode that you want. So let's say you want to play a random sequence. You will just be prompted to create a game fragment, and you will select the amount of seconds that you want to play. Let's say you want to play for 6 seconds. You hit play, and then the pads that are in front of you will light up in a random pattern, and you just hit them as they light up. Now, if you choose manual, there is an extra step. You will be prompted to the create sequence fragment, and at this point you have already configured the order that you have the pads in front of you. So let's say I want pad number 1 to light up, pad number 4 to light up, 3, 2, 1. So as you can see, it displays to you the stored order that you wanted. You want 1, 4, 3, 2, 1. And that's gonna save that pattern that you have. You select the amount of seconds that you want to play for. I want to play for 10 seconds. And what it does is, once you do that, that's the sequence fragment. It will send it to the sequence controller, store that, send it to the sequence class, and the sequence class will create and add that to the queue in the exact way and order that you created, and that will later be on display to the pads that are right in front of you. So whatever order you chose, that's the order that you'll be seeing. You hit play as a countdown, and at this point you should see the pads lighting up in that same order that you have previously stored. Then once they light up, you hit it, and at the end it'll give you your overall score. Now, if you stored a small sequence, let's say you just had 1, 3, 1, and you're playing for 10 seconds, and that sequence is finished, what it does is, since it's a double-ended queue, it would loop back and play the sequence, because once the head of the sequence has been selected, it gets stored to the back of the sequence, and then it gets played all over again. So now I'll be showing you a video of how playing the game looks like, so you can have a better idea of what I explained. Here it is.